Hello guys, I am on my next tutorial lecture on quadratic equation. Last time we described about the various quadratic equation, how to solve them, and discussed about the common roots, like suppose for one root common and for both root common. Last time I said that we will discuss the remainder theorem and working with inequalities in quadratic equation. So here we have the remainder theorem. Okay, the remainder theorem says as if we divide fx by x minus alpha and the remainder is f of alpha, and if f of alpha is 0, remember guys, if f of alpha turns out to be 0, then x minus alpha is a factor of the polynomial fx. Okay, now to describe this, let me take an example. Let me take a short example, like consider, for example, if fx, let's consider fx to be x cube minus 9x square plus 23x minus 15. Okay, now we see here that if we put 1, x equal to 1, so that is f of 1 turns out to be 0. How? 1 cube 1 minus 9 plus 23 minus 15, the result turns out to be 0. Okay, which means f of 1 equal to 0. So by remainder theorem, x minus 1 is a factor of fx. Which fx? This one. Alright, so this is the remainder theorem. So this is the remainder theorem. Alright, so next we will go on working with inequalities in the quadratic equations. So next we are going to start inequalities in quadratic equations. Okay, please listen friends, this is one of the most important topics regarding the quadratic equations. Students often they get stuck up in this type of question. To explain the tactics, let me take a very simple example. For example, fx be any polynomial and it is equal to x minus 1 whole cube, x plus 2 whole to the power 4, x minus 3 to the power 5, and x plus 6, and in the denominator part we have x square upon x minus 7 to the power cube. So here is the equation, here is the polynomial equation. Okay, so now what we gonna do is we need to, here is the numerator part, okay, and this is the denominator part. So we need to just check it out where fx is gonna be 0. Fx is gonna be 0 in at the points where x is equal to 1, x is equal to minus 2, or x is otherwise 3, or x is otherwise minus 6. Here fx equal to 0. Okay, and for x is equal to 0 and x is equal to 7, fx is undefined. Alright, fx is equal to undefined. So we need all the points. So let's draw a number line and plot all the points, and I'm going to tell you what to do. It's a very simple trick, and if you just know the perfect and if you know it perfectly, you can solve it in very quick time. Okay, so let's plot the number line. Let's plot all the points: 0, 1, 3, and 7, and minus 2 and minus 6. So at a total there are 1 2 3 4 5 6 points. 1 2 3 4 5 6 points. Okay, now listen very carefully. I'm taking it a bit slow so that you can learn very properly. Okay, so listen very carefully. Okay, first up, take a let me take a different color mark. Add plus here. Okay, add plus here. Oh, I forgot to tell one thing. The question says as prove that for what value of x is fx greater than 0. For what value of x is fx greater than 0? Okay, we need to show this. So you put a plus sign here. And we will put negative sign depending upon the value of x minus 7, depending upon the power of what the power is of x minus 7. If in the next it will be plus or minus, it will depend on the power of x minus 7. If the power is odd, the sign changes. Alright, if the power is odd, the sign changes, and if the power is even, then the sign retains. Let me check out what is the power of x minus 7. X minus 7, it's 3, so it is odd, so the sign will change, minus. Again we'll see the power in 3. Here the power is 5, again it is odd, so the sign again changes. Okay, now we'll check the power in 1. Here the power is 3, that is it is odd, then sign again changes. Then in 0, where is 0? The power is even, so the sign retains. The sign retains from this part to this part. Look friends, these are all intervals. These are all the intervals. Okay, I'm gonna tell you that, just hold on a second. Now check the power in minus 2. Here the power is even again, so the sign again retains. Here it was minus, so it will be minus here. Then again in minus 6 it is odd, so the power changes. Alright, here plus means it is positive and negative sign means it is negative. What do we actually need? We actually need where fx is positive, so we get the interval where it is positive. These are the intervals where fx means this polynomial is positive, but there is an exception. Therefore fx is greater than 0 in the interval where x belongs from minus infinity to minus 6 union 1 to 3, alright, union 7 to infinity. Alright, these are the intervals. Now if we would have greater than or equal to, greater than or equal to 10, the interval would have been like this. Square bracket means minus 6 is also included. Alright, minus 1 comma, these are also included, but 7 would be open interval. Why 7 would be an open interval? If you include 7 or 0, vice versa, what will you get? You will just get, if 7 is included, and so you have to put 7. So what comes is the fx becomes undefined. Fx becomes undefined. If you put 7 here, then it is undefined, which is infinity, which is not a valuable result. Okay, so we cannot include 7. Alright, so we cannot include 7. Likewise, if the question would have given like less than 0, then we have considered these intervals. Alright, regarding upon what the question says, choose accordingly. Okay, and see the powers, if they are even or they are odd. You apply this formula to any polynomial of the form p by q, where p and q, they are both means some factors. Now arrange them, see the views, see the powers of each of the term, and then plot in a number line like plus minus. Then you get the interval where they are positive, where they are negative, which value to take, which value not to take. So you will get very easily. Okay friends, now I'm going to show you some graphs related to quadratic equations. Alright, some graphs related to quadratic equations. Now you see, okay, in the first lecture I told the quadratic equation is in the form ax square plus bx plus c. Here a, b, c are coefficients. Now this coefficient a plays a very important role. Now as you see, the highest power is 2, so it is quadratic, and the quadratic graph, always remember, the graph of any quadratic, remember it must be quadratic equation, is always a parabola. Okay, so for friends who don't know what is parabola is of the type like this. Here is the x-axis, this is the y-axis, this is a parabola. Here the values of x goes, and here fx, y, which is equal to fx, whatever you call it. Okay, alright. So let's see some. Remember, it is always a parabola. Okay, and parabola are of the form like this. Now this coefficient a plays a very important role. I'm going to tell you how. If a is positive, then the parabola opens upside. Okay, and if a is less than 0, then the parabola moves downward side. Alright, now depending on d, the parabola also changes. Remember I said you the discriminant d, which says the nature of the roots. For number 1, for d greater than 0, the roots were real and distinct. Real and distinct means it cuts the x-axis at exactly 2 points, and depending upon the value of a, it is like this. It is for a greater than 0, it is for a less than 0. Okay, number 2, for d equal to 0, roots are real. Okay, roots are real and equal. Roots are real and equal. It shows as the graph touches the x-axis at only one point, means real and equal, both are equal and both are same. Okay, this is for a greater than 0 and this is for a less than 0. Alright, we come to point number 3. For d less than 0, the roots are imaginary. Imaginary means the graph does not touch the x-axis at all. Alright, this is for a greater than 0, this is for a less than 0. Alright, okay students, did you get it? I know it is a very bit a bit difficult to digest on the first part, but you follow my guidelines, you follow my steps, and you will find quadratic equations very easy. Alright, now I am taking the pain and doing all this just for you to learn. Okay, now we have concentrated on the graphs, so let's give you some important notes. Alright, notes on graphs. Okay, the base of the parabola has coordinates minus b by 2a and minus d by 4a. D, as you know, discriminant. What do you mean by the base? Base are like this base, this one, the least position one, minus b by 2a and minus d by 4a. In a parabola where a is equal to 0, the lowest value of the parabola comes when x is equal to minus b by 2a, and what is the value of y? The value of y turns out to be this one, which is minus d by 4a. Now if you find a parabola which is positive, remember, which is positive, the lowest value of the parabola will always be minus d by 4a, irrespective on the value of d, irrespective of the value of d. Alright, and if a is less than 0, then it will come like this, and the base is minus b by 2a and minus d by 4a. Alright, this part is minus d by 4a. Okay, now are you getting it? I know you are getting it. In the parabola where a is less than 0, the highest value of the parabola comes when x is equal to minus b by 2a, and that value is minus d by 4a. Okay, minus d by 4a. So minus d by 4a is the highest value, is the maximum value of the parabola where the coefficient of x square, means a, is less than 0. Alright, these were some of the rules, these were some of the things which you should know in solving the quadratic equation. Now I am not taking any examples here to show. I hope with these lessons you can easily tackle any questions. Alright, so next I'll be moving to one of the most important things, which is the location of the roots. Location of the roots. Remember friends, location of the root is the toughest part in quadratic equation, but I hope I'll be able to make simpler for you. So let's go. And one of the things, guys, just solve as many problems you want. Okay, solve as many problems irrespective of the author. There are many good authors in the market. You can take any one of them and practice anything. All are good. I am not taking any references because you might ask which book is good. Take any book, man. Everything is good. Okay, a book is always your best friend. So let's go to the next topic, location of roots. This topic is basically not for JEE mains. Okay, you won't find any question regarding location of roots in JEE mains. It's just a brush up for JEE advanced student who will just see how to tackle the location of the roots problem. Okay, now let's suppose case 1. If both the roots are greater than a specific number, say d, so how will the parabola look like? It will look like this. It is d, or it can be a visible one. we are not taking the case where d is less than 0, because where d is less than 0 the roots are imaginary and there is no question of having any real root which is less than an imaginary number. Alright, so you should understand at least this. Okay, so by seeing this, at f of d, what is the value? I don't know. It is f of d, but what I know is it should be a positive. It should be positive because it lies above the positive y-axis, above the 0 point, so it should be positive. Alright, it should be a positive number. Okay, so the first condition which you get is fd should be greater than 0. Alright, it should be greater than 0, and d should always be greater than or equal to 0, discriminant. Alright, condition number 2. And last but not the least condition, what I get, here is the base. Alright, the base is this one. Alright, the base, what is the value of x at the base? Minus b by 2a. When d is greater than this parabola where it cuts, so d will also be greater than minus b by 2a. d will also be greater than minus b by 2a. d is any value on the x-axis. Alright, and minus b by 2a is any value on the x-axis where the maxima or minima of the parabola occurs. Alright, maxima or minima of the parabola occurs. Alright, these are the three conditions that it must fulfill if both the roots are greater than a number, say d. And solving these three conditions, you will get an inequality, and regarding that inequality and based on that inequality you will get your following results. For what value of x, you may get a constant number, you may get a constant, you may get a variable, that depends on particularly on the questions. Okay, I'm gonna give you a set of questions at the end of the tutorials, at the end of the lectures, and I'll discuss it later. I'll give you the questions and I'll discuss it on the later tutorials, which will where we'll revise the quadratic equations. Okay, so now let's go to case 2. Case 2. Alright, so case 2, both roots lie on either side of any number, say d. Alright, both roots lie on either side of any number, say d. Alright, so the equation will look like as d, alpha, beta, which are the two roots of the equation. Okay, for this there is no other thing. First condition should be d always less than or equal to 0. It cannot be equal to 0, sorry, because if it is equal to 0 then it will coincide only at one point, and there is no question of being both the roots are real and in between I have a number d. Okay, d is equal to 0, d is greater than 0, and number 2, what is the value of f at d equal to fd should be a negative quantity. Alright, fd should be a negative quantity. Alright, these are the two equations. Solving these two inequalities, you will get your following result. Okay, and case 3. Alright, case 3. Exactly one root in the interval from d to e. Exactly one root in the interval from d to e. Look, students, it can be like this: D, E, exactly one root. Alright, D, E, or it can be like this: D, E. It can be either ways. You see, f of D is a positive and f of E, it's a negative. F of E negative, f of D positive. Here positive and negative I'm saying with respect to the y-axis value, okay. This is f of x, which is also why student gets really confused in these things, small things. This is x, f of x, which is equal to y, okay. Let's suppose y, let's suppose g, like that, okay. Positive and negative with respect to the y-axis values, okay. So what we get from both the set of drawings, we get fd into fe should be less than 0, because one is positive, one is negative, so the product will always be negative, so it is less than 0, number 1. And as for always, the universal will be d is equal greater than 0. Solving these things, you will get a inequality, and in these inequalities you will find your desired output. There is case 4, which is not likely to be found in the question papers nowadays. It used to come ahead like in my time. Case 4 is a very rare case, and I don't know, you can follow or you don't follow, that's up to you, but I am giving you for the sake, okay. When both roots are confined between D and E, and D is less than E, means E is greater than D. Alright, it is D, it is E. Alright, it is D and E. What do you find? Number 1 condition, as universal, D can be greater than or equal to 0. It can also be like this: D, E. Alright, then number 2 condition is FD is greater than 0. FD is greater than 0. Alright, number 3, FE is greater than 0. Okay, and last but not the least, this is important. What do you know? What is the coordinate of the lowest point here? Minus b by 2a. So minus b by 2a point lies between D and E. So D is less than minus b by 2a is less than E. Solving these inequalities, you will get your desired output. And you can find what the question says. So with this, the lectures on quadratic equation is finished. So at last I'll write thanks for watching this. Thanks. Oh god, THANKS, thanks. Sorry, I got a bit nervous on this thing. So no problem. Thanks to all of you guys who are watching this video, and please subscribe to my channel for more important things which are going to come, like any topics in mathematics, and regarding any issues about the video quality or about the language that I am using, or am I going too fast or too slow, please comment, guys, please comment. It's for your benefit only, please comment on my channel, on my video channel, and please subscribe to it for more interactive videos. Okay, thank you, and I hope best of luck, and please follow my guidelines on the quadratic equation so that you get no problem in the future. Thank you.